Okay, so this way we can find that VDC minus V naught by, and this is the upper section and this is second half section is V naught, that is minus V naught. So here in this case you can see that the midpoint it is cutting at the portion, if it is the IL by 2, then the middle point is delta IL by, this is the, from IL minimum to IL max is considered as delta IL. So the midpoint, which is the considered as the average of the current, that is that is each half of the average current is delta IL by 2. So IL minimum is the total current IL minus delta IL by 2. So IL will be at distance delta IL by 2. So IL minimum is IL minus delta IL by 2 and IL maximum will be IL plus delta IL by 2. This is our IL, this value. This one is the IL. So IL minus delta IL by 2 is IL minimum. IL plus delta IL by 2 is IL maximum, this value. Okay. So during the on state, the voltage during the on state, switch voltage is equal to 0 and current is infinite. During off state, switch voltage is finite and switch current is 0. Now, if you can see in this picture that VL here also, the output, average of output, that is average of VL will be equal to 0, because this half, that is positive and negative half cycle, will be similar. How it will be possible, that I can show you with an example. Suppose DC voltage is 300 volt supplied. Okay, output voltage is 100 volt and the duty ratio given is 1/3. Then VL on will be equal to this VDC minus V naught into on time, and off will be equal to V naught into one off time, because during the off time this is the voltage equal to minus V naught. So during off time the inductive voltage equal to V naught into off time, and during on time VDC minus V naught into on time. So VL on equal to 300 VDC minus output voltage 100, that into D is given as 1 by 3 T. So 200 by T, 200 T by 3, and VL off will be equal to V naught is 100, 1 minus 1 by 3 into T, 200 by 3. So both will be same and the VL average equal to 0. So this way we can get the VL average. So the inductor is called volt second balancing. Now the ripple current is mm, ripple current here is delta IL. So during on time, IL inductor current equal to VDC minus V naught by L into T plus IL minimum. At T equal to dt, IL equal to IL max. So IL max equal to, so you just put this value IL equal to IL max So you'll get this one. IL max equal to, this time T is dt plus IL min. So from that we can get IL max minus IL min equal to VDC minus V naught by L into dt. So IL max minus IL min equal to delta IL. So delta IL equal to this. So this is our maximum ripple that is available. So what will be the maximum ripple available will be delta IL max. So this will be dd of delta IL equal to 0. To make it maximum, we have to derive it with respect to d and make it 0. So from that we will get duty ratio equal to 0.5. Okay. So delta IL max will be equal to VDC by 4 L into this L into F. Increasing switching frequency, ripple can be omitted. Okay, for high switching frequency, we will use MOSFET. So we have another charge storing element also, that is capacitor. Now we will discuss how to deal with capacitor charge. So similar way we can see that in this picture, in the previous picture, in the buck converter, what we have seen. So IL is equal to what? IC plus I naught. This is not I naught. This is IC. The current passing through capacitor is IC. Okay. Current passing through capacitor is IC. So this is IC. This one is IC. So you can see I naught plus IC, I naught plus IC is equal to IL. Okay. Therefore, from that we can get IC is equal to IL minus I naught so now we will see the waveform, how it is acting uh, mm, before charging and discharging. Okay. Now, uh, this portion is the inductive voltage portion. So this is, we have seen that in the previous diagram, that this is inductive portion and the switch is on and off this way. This is dt and this is 1 minus d into t, and this total is the t. So during the period of charging, it is starting from a certain point. It is also not touching the zero axis. So during that point to this value, suppose this is also the, this is actually the IL line. Okay, this is the, this line is IL. So below the IL line, the capacitor was in a discharging mode. So here output current is greater than the inductive current. During that period, inductance is getting charged slowly from initial period. During that period, capacitor is in discharge mode. So this portion to this, that is up to IL, it is slowly charging, but it is in a discharging mode. Okay, at IL point to IL maximum, this point is the charging time. So IC here is negative, this is discharging. So if I say this time, that is it is cutting IL line, let us consider this time as T1, and at time it is again discharging and crossing IL line is T2. So this way it is going on, it is repeating. So capacitance is ampere second balance. So the stored and discharging energy is same. So from T1 to T3, from T1 to T3, the time period is total time period. So your capacitance cycle will be from T1 to T2 and from this to this. Okay, this is a complete cycle of capacitor charging and discharging. Clear? So total time period is from T1 to T3. Now from T1 to T2 is equal to total time period by 2 or half time period. Now the capacitive voltage, if the capacitive charge is delta Q, so change in charge, let us consider as delta Q. This is the change in charge. Okay, and during that change in time, the ripple voltage we will get, let us consider that ripple voltage is V naught, then it will be equal to delta Q by C. This is our ripple voltage. Now the time, now what will be the value of this? This will be equal to the charge here, delta Q by C will be the charge stored in the inductor. During the period the inductor charge stored, that is from T1 to T2, this portion will be delta IL by 2, that into the time period is T by 2. So it will be half into T by 2 into delta IL by 2. So this is the value of ripple voltage. Okay. So it will be equal to delta IL, this is IL, delta IL into T by 8. This T is actually the crossover frequency, so it can be written as CF. So delta IL by 8 into CF, cross frequency. Okay, so maximum ripple voltage also we can get by deriving this delta V0 with respect to duty cycle. And again we will get duty ratio equal to 0.5 from this equation. So this will be similar like inductive voltages. And maximum output voltage we will get from this will be equal to VDC by 32 LCF square. So this is our maximum ripple voltage, and maximum ripple current we got IL max is equal to VDC by 4 LF. Okay, so this way we will get the value. So here you can see the similar thing is written, IC equal to negative when discharging, and T is between T1 to T2 when IL is greater than I naught, IC equal to positive when charging. So capacitance is ampere second balance. So the stored and discharging energy is same. From T1 to T3 the time period is T. So from T1 to T2 the time period is T by 2. Now the voltage, ripple voltage is delta Q by C. Change in charge. Change in charge is delta L by 2. That into the on time T by 2. And the ripple voltage is this. This is the ddt of V naught V naught is this VDC minus dVDC into dt by 8 LCF. So from that you will get ratio, duty ratio. Okay. So